then?
Oh, some of them are like students, right? Good summer job though, eh? 127K a year, plus
What?
expenses. MLA pays 127K.
Can I be an MLA?
Sure. If you'd run for the NDP, you might be at this very moment.
God damn it.
Yeah, I know, eh? It's like, wait, I could have.
Damn it. Why
Anyways, area between curves and antiderivatives. So we've done the area between a curve and the x-axis and then a couple of boundaries, right? Like from A to B. So yeah, that's what this says. We also want to find the area between two curves. So let's look at an example. So we've got the graphs of y equals 4, and y equals 2x. And we're going to go from -3 to 5. So that's -3, and that's 5, and this is where they meet, which is 2. And we want to find this area, right? Now we can just use basic geometry, right? It's just two triangles. So we can fill in some numbers. This goes from -3 to 2, which is 5 units. And this goes from 4 to, down here, that's the point -3. And since we've got 2x, that's just -3, -6. Okay, so then these guys here are 10 units apart. So that's one triangle. And then the other triangle goes from 2 to 5, which is 3, and from 4 to, and again, what's this? So this will be 5, 10. So this will be 6 units here, 6. Okay, so we just do the area. It's the sum of two areas. So A is equal to, so let's call them A1 plus A2. And we'll call this A1. And we'll call this A2. Okay, so A1 is 1/2 base of 5 times a height of 10. And A2 is 1/2, and we got a base of 3 and a height of 6. So this is 25 plus 9, which is 34. Okay, and I'm going to leave off the units. It's okay, right? It's an area, and we know it's square units or units squared, but we'll just go with the area is 34. Now the question is, well, can we use antiderivatives to determine the area of the shaded region? And we can sort of think, well, yeah, we can, but we've got an area below here, right? Now the thing is, if you use antiderivatives and there's an area below, it's going to come out as a negative. Now that's fine, right? We could deal with that because all we got to do is take the absolute value of it, right? So we're interested in the amount of area, not in whether it's above the axis or below the axis, but just the amount of area. And it turns out actually that to find the area between two curves, because we think about it, right? You'd figure out this area, let's say the area underneath 2x, and you would subtract from it this area here, right? And we could do that with antiderivatives. But it turns out that if you take the difference between the two functions and then do its antiderivative, you get the same thing. Same thing happens, right? So let's give that a try. That's what this example is going to show us, right? So we have two functions, y equals 4, y equals 2x. Seeing as we're going to take, now usually the way it's worked out, and a lot of times you'll see it in books done this way, is they'll say, let's take the upper function minus the lower function, right? Because that will give you that will always give you a positive area, right? If you take the upper function minus the lower function. So the upper function here is 2x and the lower function is 4. So we would do 2x minus 4, we would find its antiderivative, and we would evaluate it from, where is this, 5 to 2, right? And then we would take 4 minus 2x, find its antiderivative, and evaluate it from 1 to -3. Turns out we don't have to do that if we just do an absolute value, right? But we still do have to split this into the two different regions, right? Otherwise, if you just try and do the whole thing at once, you'll end up adding on a negative area, and that will reduce the whole area. We don't want that, right? So we just say, okay, we're going to do two separate things. So our choice now is, do we want to do 4 minus 2x or 2x minus 4? And so we say, let's do 2x minus 4. So we're going to call a function. So let's say, let f of x be 2x minus 4. Then, capital F of x, which is the antiderivative, right, is x squared minus 4x. plus c, right? But we're going to leave that off. We know there's a plus c there, it's the general antiderivative. But since we're working out an area, and we're going to have f of something minus f of something else, the c's are going to cancel. So we're just going to leave them off. And so we'll say, okay, what's the area? So the area is the absolute value of f of, what's our far end? F of 5 minus f of 2 plus the absolute value of f of 1, that's our upper bound, minus f of negative 3. Okay, so we have to split this into two regions, right? So we've got from 5 down to 2, and we've got, oh, that should be a 2, not 1. And we've got from 2 to negative 3. All right, so all you got to do is plug in. So it's the absolute value of, so f of 5, and what I'm going to do is I'm going to evaluate this just inside a set of parentheses, right? So I'm going to say, all right, so it's 25 minus 20 minus, and then the real reason I'm doing the parentheses is because I want it in front of here just so I remember to subtract. And if there were expressions, which this will just be numbers, so we're okay. And the numbers for f of 2, it's going to be 4 minus 8 plus the absolute value of, so f of 2, which we've already done, right, is 4 minus 8 minus, and then we've got f of negative 3, which is going to be 9 plus 12, and that absolute value. All right, so are the two values the same? Maybe. I don't know. We're not there yet. Okay, so what do we got here? We got 5, absolute value of 5 minus, and that's going to be, what, negative 4? Plus, and here we've got 4 minus 8 is negative 4 minus, what do we got, 21? So 5 minus negative 4 is 9, and that's negative 25. And so absolute value, 9 plus 25, or 34. Whoa, whoa. Yeah, yay!
This is not spectacular.
Wow, no, really? Is the other one was, I know, that was spontaneous. That was quite,
This one we knew.
well, we knew the last one too. It just, so are the two values the same? Yes, they are, right? And even though one area kind of works out as a negative, right? And if we had flipped this around and done, instead of 2x minus 4, done 4 minus 2x, then this would have come out as a positive. So what happens is, if you do upper minus lower, your area is always going to be positive. Whoa. If you just choose to do one minus the other, but do absolute values of the areas, then you will have negative, negative areas, but they will become positive, right? So we're interested in the size of the area. So in general, if f of x and g of x are two functions such that f of x is always greater than or equal to g of x on the interval a to b, then f prime of x is f of x minus g of x, and the area between f of x and g of x can be determined by f of b minus f of a. Okay? Now what we have to realize is we have to find those crossing points, though, right, in the areas. We have to evaluate in each interval. All right. Determine the area between y equals 2x squared plus 3 and y equals x plus 1 from x equals 1 to 4. Okay. So usually what we want to do is kind of make a rough sketch just to get an idea of what are we looking at here and do these things cross. I mean, likely this is just nice little boundaries here and that, but let's sketch it out. Let's do that over here maybe. So 2x squared plus 3 is just going to be a, narrower parabola, and then x plus 1 runs there, and so it's not like they intersect, right? So it's not sort of the area it's not the area in between them in that the line goes through here, right? And you can say, oh, well, we're going from here to here, right? In this case, we're said we want the area between this 1 to 4, x plus 1, and y equals 2x squared plus 3. Okay. So we can say, all right, well, the upper function then is 2x squared plus 3, and the lower function is x plus 1. So we're going to let f of x be 2x squared plus 3 minus x plus 1. So it's going to be 2x squared minus x plus 2. And then we're going to get the antiderivative. So that's going to become a 3, so 2/3 x cubed minus x squared over 2 plus 2x plus c, which we're not going to use in this context, right, because we know we're going to be subtracting. And the area that we're interested in will be f at 4 minus f at 1. And all we got to do is keep in mind when we're working this out, we've got two different expressions, right? We've got f at 4, so I'm going to separate that out instead of parentheses. Oh, and really, in this case, it won't matter, but it's the absolute value of. Now, in this case, since 2x squared plus 3, or whatever the heck it was, is always above x plus 1, this will come out as a positive area anyways. Okay, so it's the absolute value of, and we've got 2. Yeah, okay. 2/3 times 4 cubed minus 4 squared over 2 plus 2 times 4 minus, and then we've got 2/3 1 cubed minus 1 squared over 2 plus 2 times 1, absolute value, equals. Okay, so that's 64. We're going to get 128 over 3 minus 16 over 2. Let's just call that 8 plus 8. Okay, nice, because those are gone. Minus 2/3 minus 1/2 plus 2. Okay, so minus 8 plus 8 are take each other out. So it's the absolute value of. So let's put it all over 6, right? Because 6 is going to be our common denominator. I'm going to collect all these terms. 6. All right, so this becomes 256. These are gone. We've got minus 2/3, so you're going to go minus 4. We've got plus 1/2, right? Minus negative. Plus 1/2 will become plus 3, and we've got minus 2, which will be minus 12. Okay, because 2 has got to become 2 over something over 6. That's 12 over 6. All right, so what do we got? 259 minus 16, 243. 243 over 6. Okay, well 6 goes into 243 40 times, right? 6 times 40 is 240, and then you got 3/6, so it's 40.5. And it was already positive, right? I mean, since the one function was always above the other, this was going to happen. That area is just always positive. Yeah, 40.5.
If it is always positive, do we still need to show the absolute value sign to get full marks?
No.
Okay. Will we
Just-
lose marks if we did?
You just need to be absolutely sure that it's always positive. Yeah. Or the other way you can do it is you can do the two areas separately, right? You'll have to do two antiderivatives. I mean, they're very similar, right? You've got all the same terms, but you would have to do one over the other. So, if you looked at last year's stuff, you would see me do, okay, this is the upper function here, we're going to do upper minus lower, and this is the upper function here, we're going to do upper minus lower, we're going to work out the two antiderivatives, we can add them. There's no absolute value signs in sight, right? This way, it just becomes easier. Turn there between sine x and cos x from 0 to pi over 2. Okay, definitely gotta sketch this out. So 0 to pi over 2. There's pi over 2. And this is sine x. And cos x does this. And that makes this. And that makes this pi over 2. And that's 0. So where's this? Pi over 4. Right? So where is sine equal to cos? At pi over 4. So we have to do two separate areas. Matter of fact, you know what? Let's do this one with the upper minus the lower. So we'll end up doing two antiderivatives, but they're kind of the same, right? Very similar. So we'll say from 0 to pi over 4, we're going to do cos x minus sine x. Okay, so let's say from 0 to pi over 4, f of x is going to be cos x minus sine x. So capital F of x is what? Well, derivative of sine is cos, derivative of cos is minus sine, so we get sine x plus cos x, right? Or from 0 to pi over 4, we're looking for this, right? We're doing sine x plus cos x. From pi over 4 to pi over 2, then our function, again, we want to do upper minus lower. Now in this case, the upper is sine x and the lower, so it'll be sine x minus cos x. And the derivative of that, or sorry, the antiderivative of that, and if I said derivative before, I meant anti, will be negative cos x minus sine x. You see, yeah, they're kind of the same, but this is the negative of that, which is going to make this area positive now. Okay, and otherwise, if we had just used one or the other, then one of those areas would come out as a negative, like when you've got lower minus upper, but the absolute value would make it positive. All right, so the area, let's call this F1, and we'll call this F2, and we'll call this little f1, F2. Okay, so the area is, now we don't need absolute value now, so we need F1 from pi over 4 to 0 plus F2 from pi over 2 and pi over 4. Okay, so F1 at pi over 4. So, okay, let's put down the big bracket, which is enclosing this, right? We're going to work this out separately, just to sort of keep it, so if we look down, we can say, oh, that's that. So F1 of pi over 4 is sine pi over 4 plus cos pi over 4 minus, and F1 of 0 is going to be sine 0 plus cos 0 plus, and we get another set of brackets, and we're going from pi over 2, so this is minus cos pi over 2 minus sine pi over 2 minus, right, that minus there, and then we've got minus cos pi over 4 minus sine pi over 4. And another bracket to close that. Equals. Okay, so now what we're going to do basically is remove all the brackets, just write everything down. So sine pi over 4 is root 2 over 2. So we got root 2 over 2 plus root 2 over 2 minus, okay, the sine of 0 is 0, minus the cos of 0 is 1. Okay, so everything's just paralleling down, right? Minus, and you make sure you're using distributive law. Minus 0, minus 1, plus, so that plus is there, the negative of the cos of pi over 2, well, cos of pi over 2 is just 0. So we can write minus the sine of pi over 2, so it'd be minus 1, minus negative cos pi over 4, right? So that's going to become plus, okay, cos and sine of pi over 4 are root 2 over 2, right? So minus, this will become plus root 2 over 2, and this will become plus root 2 over 2. All right, so we have how many root 2 over 2s? 1, 2, 3, 4. We got 4 halves, which is going to be 2 of them.
So
2 root 2, yeah. Or 2 times, yeah. So many 2's. Or 2 root 2 minus 1. Okay, so remember, the idea is you kind of sketch it out and you have to find the intersecting areas, right? So you have to determine which intervals am I doing. And in this one, right, everything just worked out positive, right? It's 2 root, this would be root 2 minus 1, which is a positive number, plus 1 minus root 2 again. Determine the area between y equals 2x minus 3x plus 1x minus 4 and y equals negative 6x plus 12. Okay, so negative 6x plus 12 is a nice little straight line, and the other one is a cubic. And I mean, for sketching purposes, the left-hand y, that's kind of nice. We know where the zeros are. We know that it's positive. It goes Q3 to Q1, right? It's an increasing. And the negative 6x plus 12 is coming down this way. But if we're going to find out, well, where do these intersect, right? Because what areas, and when we say the area between, that means they must intersect. So there are a couple of areas that are in between them, as opposed to say the x squared plus 1 and the x plus 1 in this bounded by these x values, right? In which case the area between them wasn't strictly between them, but was defined by x boundaries, right? And you'll get that in the book. There's a bunch of phrases. Find the area, blah, blah, when x is between here and here. In this case, there is a between. So I think we have to multiply this out. So this is going to be x squared minus 3x minus 4. And this is going to be 2x cubed minus 6x squared minus 9x squared minus 8x minus 9x minus 17x plus 12. Must check sheet. No, I messed something up there. I messed up the x. What did I do? My x term is bad. It's like minus, oh, it's plus 9x. Minus 8x plus 9x, be plus 1x. Shouldn't have tried to do it on one line. Yeah, I know. Well, this is correct. Okay. Now, what we need to know is, fine, where do these two guys intersect? Right? Then we'll draw a little sketch of it just to get an idea. Okay, so we're interested in what? Where 2x cubed minus 9x squared plus x plus 12 is equal to negative 6x plus 12. Okay, so the 12s go. So we get 2x cubed minus 3x squared plus x is equal to 0.
No, that's only a single x, not an x squared.
Yeah. Minus 9x squared. I wish I could say I was doing this on purpose. All right, so we can factor out an x, right? So we'll have a 0. It's they're gonna. And we get 2x squared minus 9x plus 7. And my 1 minus, yeah. 2x squared minus 2 minus 7 is minus 9 plus, yeah. Okay, so we've got x equals 0, x equals 7 halves, and x equals 1. Okay, so if we sketch this out, I'm going to do where? Let's just do that down here. So let's say y equals negative 6x plus 12, right? So we know that that's a 12, and we know that this, to get a 0, this will be a 2. And we've got zeros on the original function of 3 halves, negative 1, and 4. So 4, negative 1, and 3 halves. Okay, so this function's going to do, oh, and the other thing is This function has a y-intercept of 12, right? Which we know it's got to intersect at 12 because the 0, the 3.5, and the 1. Okay, so it's going to come up here, intersect here. It's going to intersect at 3/2. And where was the other place? 0, 3/2, and 1. Oh, okay, hang on. So it's going to come here at 1, and then head down and come back up and go through. It's kind of ugly, but here's the area we're looking for. So basically between 0 and 1, and between 1 and 7/2. Oh, wait, 7/2 is 3.5. Idiot. Ugh. 2, 7/2, 4, or the other 0. 3/2, -1, 3/2, -1, 12. Okay, so they're going to cross here. 3/2 are going to cross here at 1, and they're going to cross here at 0. And it's got a 0 there, and then there. Okay, either way. Okay, we got 0, we got 1, and we've got 7/2. In a sense, you didn't need to draw the diagram. Drawing the diagram would help if you were always going to go for positive areas, right? So if you're going to work upper function minus lower, and say, well, okay, let's take this minus this, and then on this one, take upper minus lower, then you'd need the diagram to know which was upper and which was lower, right? Now in this case, we don't really need that. We just need to know that I need to go from 0 to 1, and from 1 to 7/2. And we've already taken this, right? That's capital F of x, right? Because it's f of x minus g of x, right? It's this function minus this function. So that's not capital F, right? That's little f of x is 2x cubed minus 9x squared plus 7x. 2x cubed minus 9x squared plus 7x. So now we do the antiderivative. So we got to increase that to a 4, right? And then you're going to multiply by 4, so put that over a 4. So it's x to the 4th over 2. That becomes a 3, so 3x cubed, right? And again, just, take the derivative of each term as you do it. So you say, well, this is 4 times x cubed over 2, which is 2x cubed. This is minus 9x squared, okay? And this is plus 7/2 x. General antiderivative plus c. Okay, now since we know we're doing areas, and we've got 2 areas to do, and nowhere near enough width here. Let's squeeze it in here. So the area is going to be the absolute value. So let's put down the expression first. So we've got f of 7/2 minus f of 1 plus f of 1 minus f of 0. Okay? So we're working out 2 separate areas, right? Which in our diagram corresponds to these 2 separate areas. So between from 1 down to 0, and from, that's just a bad drawing, that should be like that, and from 7/2 to 1. Okay, so all we do is start plugging in, right? So we've got 7/2. So I'm going to take that 2 and just go 1/2 times 7/2 to the 4th minus 3 times 7/2 cubed plus 7/2 times 7 halves.
That should be squared. 7 plus x.
Right. Squared. See how easy it is? Just one little thing. All right, I'm just going to do it off the piece of paper where I actually wrote it down correctly. Okay, that's this. Minus, okay, let's not get too technical, right? It's going to be a half minus 3 plus 7 halves, right? There's no point putting a 1 in there to the fourth and all of that, right? It's a 1, so this is 1 half minus 3 plus 7 halves plus, okay, and I'm going to have to go down here. Now, luckily, there's repetition, right? Like when you're doing this, because you split the area at something, so the f of 1 we've already worked out, right? So it's just a half minus 3 plus 7 halves minus, and then we've got f of 0, which is 0. Okay, and that often happens, right? Or at least if you get an f of 0, it's kind of nice, because it's just, you know, it's 0 minus 0 plus 0, it's just 0. All right, so we really got two things. We got to work out this, we got to work out this, and then this and this are the same. Okay, I'm going to give you the numbers. I've worked it out. It's doable by hand. I've worked them all out by hand because I didn't feel like reaching for my calculator. So 7 to the 4th is 2,401, and we've got 2 to the 5th, so that'll be over 32. Minus 7 halves cubed is 343 over 8, and 3 times 343 is 1029 over 8. Plus, and this just works out to 7 halves cubed, so it's 343 over 8. Minus, and here, so a half plus 7 halves is 8 halves, which is 4. Minus 3 is 1. So this just works out to 1. Okay, so we go minus 1. Plus the absolute value, well, this just works out to 1. Okay, so we need a 32 in the denominator. So we get 2401 minus 4116 plus 1372 minus 32 all over 32, and then plus 1, we just take the absolute value of 1. And this first area is actually negative, right? Because what we call the upper function is really the lower function in this case, the way we did it. So this works out to negative 375 over 32 plus 1, which is 375 plus 32 over 32, which is 407 over 32.
So are we going to be expected to make those kinds of calculations on a test?
Yes, but we'll give you time.
You're Amos.
They hate us and they hate us.
At some point, yeah, they're, you know, like if you look on here, they're all there. It's all off to the side. Here's what I did. What's 343 times 4? What's 1,029 times 4? It's not really difficult, you know.
There's no
And
reason we get scrap paper.
you know what? Like, if you're strapped for time or whatever, get it to this point and leave it. At least, at most, I would take off like 1 at that point. Like if all that was right, it's just from that point on, it's arithmetic, right? So you could lose a half a mark by blowing stuff in here. You know this is going to take time, but hopefully on the test you have the time to come back to it and just, well, you definitely have time to come back to it and say, okay, let me just pound through the numbers now, right?
Another company, so I can get it.
I think we went through the. Oh yeah, gate does not get you
You
extra
have to be
time.
an extra special kid.
Yeah, you have to be a subset.
Just
Probably
write
be
that.
3/4.
That's why I get extra time.
I write 3/4
of it.
If you're trying to.
Sometimes,
Sound like a
given a finite but large amount of time, it makes no difference in what you're going to get. Right?
Yeah, about 2/3 of my extra time is me just sitting there on a question I'm gonna.
Okay, so we kind of know what these things look like, right? Quadratic, move down 4, straight line, and another straight line. And we're just going to go in here, take a look, okay? And I guess we'll have to zoom in a smidge
Zoom out.
and move it down a bit. And zoom in a bit more.
But necessarily.
Okay, so here's the area we want, right? This and this. So the idea here is we got to figure out, well, how are we going to split this, right? Like, where does it change? So we could say, you know, from here to here, the green line, which is 6 minus 3x, is the upper function, and the lower function is x squared minus 4. But at this point here, which is 1, but we'll figure that out, right? Because we have to go through an algebra to see where do these things intersect, right? So we have to know that. At this point, then this becomes the upper function. So that in here, okay? So we have two areas, right? And they're split down here. So A1 and A2. And they'll actually require two different calculations, right? Because the area here, and we can actually put the upper function on top if we wanted to, just to get positive areas and not do an absolute value. Okay. So here, the upper function of A1 is 6 minus 3x, and the lower function is x squared minus 4. And then here, for A2, the upper function is 3x, and the lower function is x squared minus 4. So we have to do two areas, but they're two different areas, not two different areas as in, hey, we're using the same capital F, but we're using two different capital F's.
What about the third one?
Which third one?
The one between these two and going down.
Okay, so do we have? All right, so what's
Talking
the?
about?
So okay, here's A1.
Oh, okay. Never mind. A1 includes it.
And then here's, trust me, I was sitting looking at it last night and going, there's like 5 different areas here. And then,
Okay.
yeah, just looked at it again. And, oh, no, actually I didn't know. Melchuk said there's only 2 areas. And I said, oh, you're right. There's only 2 areas.
You erased one.
I took out a line. 6 minus 3x. Okay. Okay, so 2 areas, right? But here's the important point, or the important area. All right, so what we have to do is we got to say, okay, where is x squared minus 4 equal to 3x? So this is x squared minus 3x minus 4 is 0, and this is x minus 4 and x plus 1. So we've got x equals 4 and x equals negative 1. Okay. Now pretend we haven't seen anything yet, because we'll take it from we didn't see that, and let's do x squared minus 4 is equal to 6 minus 3x. So this will be x squared plus 3x minus 10. So that's x plus 5, x minus 2. So x is negative 5 and positive 2. That's where those two guys intersect. And then we need 3x and 6 minus 3x. So 3x equals 6 minus 3x. So 6x is 6 and x is 1. Okay, so we have the intersections of each of the 3 functions, right? And now we should be able to sketch this out and kind of put the points. All right, so we know that we need x values of negative 5, negative 1, 1, 2, and 4. So negative 5, negative 1, 1, 2, and 4. And this guy is a negative 4, so x squared minus 4 is down here, right? So we need this guy at 4, so 4, 12, right? When x is 4, this is 12. So we've got the point 4, 12. And when this is negative 1, then this will be negative 3. So negative 1, negative 3. And this was just 3x, so the 3x is going to go like this. And at this point and this point, that's where the quadratic is going through it, right? Then we've got x squared minus 4 and 6 minus 3x, so they're at negative 5.
Intersect with 0.
Who what?
Shouldn't 3x go through the origin?
Yeah, it should. This is just allowed to die. If I could move, oh, I can't. I almost did. Let's put that back. See if I can move the. Okay, can I move you now? There, better?
Sure. You did it.
You know what? I'm better off not putting down a set of axes, I think. Because, yeah, no, I got to put that back. Just, it should go through 0, but it's just a sketch. Negative 5. When x is negative 5, we're going to get 6 minus, no, it's going to be 21. 6 plus 20, 6 plus was 21. So negative 5, 21. And 2, 6 minus 6 is 0. So this line, 6 minus 3, wait, 2, 0, yeah. So del 6 minus 3x is coming down like this. And the quadratic is going through there. And the quadratic, so these guys are intersecting at 1, the two straight lines. And the quadratic is hitting at 12, 4, 12. 3x hitting there at 4. No, it's hitting at negative 1. I don't know. Something like that. Okay. So the idea is that this function is above this to here, and that's where we want to split it out, right? So from 5, negative 5, to positive 2, that's the upper function. Okay, so from negative 5 to positive 2, the green line, which is 6 minus 3x, is the upper function. And then from 2 to 4, then 3x is the upper function. So from negative 5 to 2, well, let's say x equals. So from x equals negative 5 to x equals 2, what did we say the upper function was? It's going to be this guy, 6 minus 3x. 6 minus 3x is above x squared minus 4. Okay, in that case, let's do our function, our little f of x, little f1 of x, is 6 minus 3x minus x squared minus 4. Minus x squared minus 4. So that's 6 minus 3x minus x squared plus 4, or negative x squared minus 3x plus 10. Okay, which gives our big F1 of x as negative 1/3 x cubed minus 3/2 x squared plus 10x. Okay, and remember, that's from negative 5 to 2. So we're going to work out a1 being from negative 5 to 2 of this function, and we figured this is the upper, this is the lower, so we won't have to do an absolute value on this. And then if we go from 2 to 4, so from x equals 2 to x equals 4, 3x is above x squared minus 4, So f2 of x is going to be 3x minus x squared plus 4, or negative x squared plus 3x plus 4. So big F2, be negative 1/3 x cubed plus 3/2 x plus 4x. And now we get to work out the area.
3 times x.
Right. Thank you. Okay, I'm going to start leaving things off on purpose. I'm usually better when I'm not doing this in front of a group. All right, so our area is equal to, now we don't have to do absolute values, right? So the first area is F1, where was it going from? 2 down to negative 5, so F1 of 2 plus the second area, so F2, and that was from 4 to 2. All right, and I changed the question from what I worked out, so this one we're just going to do this. Okay, what was F1? Okay, so here we go. F1 of 2, negative 1/3 2 cubed
Too late.
minus 3/2 2 squared plus 10 times 2. Okay, minus, and then the same thing but with a negative 5, so negative 1/3 negative 5 cubed minus 3/2 negative 5 squared plus 10 times negative 5. Okay, so this is this plus F2 of 4. Okay, so negative 1/3 4 cubed plus 3/2 4 squared plus 4 times 4 minus negative 1/3 2 cubed plus 3/2 2 squared plus 4 times 2. Bracket, bracket. Like, always start these things at the extreme left-hand edge, because they can get kind of big.
Because, yeah, stuff and reading.
And as you know, you can almost, like, I'd say most of your marks are to this point, right? Because now it's just arithmetic. So if you're worried about time, stop here. Go on, do other stuff, come back later, right? Like, do all the arithmetic at the end. Just say it's just arithmetic.
It's just a rep.
Okay, what do we got? Negative 8/3,
What could go wrong?
4, 2, 4, minus 6, plus 20, minus 125 thirds. That's going to be minus 25, 75 over 2, minus 50. Okay, so that's going to be a plus 50, right? Like, you know, area-wise, like when it all comes out. Plus negative 64 thirds. 16, 2, 16 goes 8, so plus 24. Plus 16 minus negative 4 thirds plus 3/2 of 4, 12, 6, plus 6. I think I already worked this out. No, it's similar, but not quite the same. Plus 8. Equals. All right, if you see anything wrong, let me know. Yes. Which one?
That last one, the negative 4/3 should be negative 8/3.
I have That should be a cube,
It
right?
is 2 cubed.
Okay. Anything else?
I don't know, I wasn't really on the attitude, but.
No. Just look. Trust me. Do I think I did? You know.
Is this mouse stone again?
What can we do with this guy? So let's go with a common denominator of 6, right? So what I'm going to do is throw down a big 6. Throw down a big 6. So this will be negative 16 minus 36 plus 120. Now watch this, right, because you're distributing the negative through. So this will be minus 250 plus 225 plus 300. Okay, so watch out because you're distributing the negative through. I've changed it. So if this is multiplying by 2, this by 3, and this by 6, it's going to be minus plus plus. Here, the 64, so negative 128. 24 times 6 is 144, so plus 144. And 16 times 6 is 96. Minus a negative, so this will be plus 16, and then these guys are minus, so minus 36 minus 48. Okay, so we just gotta get a negative 25, that'll give me a 275. 295, 395 minus 48. 7, 4, say 347 over 6. Uh, 128, 144, I think it's 16, right? So plus 16, 32, minus 4, 92, minus 48. 92, 42, 44. Yeah? Damn it! Oh, good. Oh, okay, I blew some. 343. Thank God for calculators, right? I'm looking through the test right now, so any of these that come up this way, like I'm going to suggest, I want to just leave it as just express it and, working it out. Okay, what's the second one come out to? Wait, I was right then, it is 44. Okay, so what does that give us? That's a 7 and an 8, so 387 over 6. So that'd be 60 would give us 360, 64 and a half? 64.5. Let me show you something. Control T. Oops. Area between. The area between curves calculator. Wolfram. So if you know Wolfram, okay, there's a widget for that. There's a Wolfram alpha widget. Let me scroll the screen slightly just so that we're. Oh, I can't. All right, hang on. I'm just going to move that up. So, if you want to work out the area between, so enter the larger function. Okay, so what was our first one? The larger function was 6 minus 3x, right? Okay, so I'm going to go here. 6 minus 3x, and the other one was x squared minus 4. And where were we doing that from? So it was like negative 5 to 2, was it? Negative 5 to 2. To 2. Calculate. Okay, so 57.167. Like, no. Maybe I can write that up here. 57.167. That's 57 and 1/6, right? 0.167. Trust me, it's 1/6. Okay, the other one. The upper function was 3x, right? So 3x. The lower function was x squared minus 4. Where were we going from?
2 to 4.
2 to 4, so lower bound will be 2, upper bound will be 4. Okay, so number 1, what did we say it was? Was it 64.5 or 60.5? 64.5, okay. So that means we're going to need 7 to get to 64, and then 1/3. 7 1/3, right? Okay, so calculate. I haven't done this before, so I'm just sort of hoping. 7 1/3. Huh? What? No. Whoa.
Whoa!
Thank you.
God diggity damn.
Okay? 64.5. Alright, that was kind of cool. Right? Now, this is what you're going to end up doing, but that's next unit stuff. Okay, that's integrals, right? And integrals is the next unit. So for now, it's antiderivatives. Integrals are the next unit. That's how you do this.
Thank God.
Okay. Yes, thank God. That's actually pretty much the same. So don't think, wow, it's like going to be totally different and easy. No, it's pretty much kind of the same, but it's just a different, slightly different idea. All right, 64.5.
When does this happen? Where were they done?
Who cares? We're done now. It's like.
Oh,
Okay, oops, slight modification here. When we split the area on 2, I'm trying to draw here, I can't draw, but apparently I can zoom in. Okay, when we split the area 2, we left out this little triangle here, which has a height of 6, sorry, well, a height of 1 and a base of 6, so this is 3 square units. And got left out. So the split should have occurred at 1. So we were working out the area here. So from here to here, and then all of this. And then worked out this area here, which would then not leave this out. So what's that going to look like? Well, let's go do it. It's going to look like this. And hang on, so I'm just going to be more or less copying a lot of stuff from before. So, okay, so we need the 3 points of intersection here, here, and here, right? And we're going to do 2 areas, the one enclosed to the left of this line and to the right of -5 in here, and then to the right of this line, which will be this whole area here, including the left out triangle from before. So first step, just kind of redoing the whole thing, is, so let's sketch this out. We have the quadratic, we have the line coming across here, we have the line going across here. And if you look at the previous page, or you were doing this before, you know that we have the values where x is -5 and where x is 1 and where x is 4. So we're basically looking at doing the same thing as on the previous page. Let's pop into here. So we're just taking this, same again, but we're doing F1, so let's recopy that. So, well, in this case, we'll go -5 to x equals 1. Okay, so let's write that out. And you can just sort of skip ahead if you want. So from x equals -5 to x equals 1, and 6 minus 3x is above x squared minus 4. So f1 of x is 6 minus 3x minus x squared minus 4, or -x squared minus 3x plus 10, meaning f1 of x is -1/3 x cubed minus 3/2 x squared plus 10x. And from x equals 1 to x equals 4, then 3x is above x squared minus 4, giving us f2 of x is equal to, where are we, negative x squared plus 3x plus 4. And then f2 of x is negative 1/3 x cubed plus 3/2 x squared plus 4x. Okay, so the area is equal to f1 of 1, this time it's 1, minus f1 5 plus f2 of 4 minus f2 of 1. And we don't need absolute values since we've chosen each function as the functions above, so now we're filling in. So we have negative 1/3. Well, so we're just doing 1 here. It's just going to be negative 1/3 minus 3/2. And we're doing 1, so plus 10. Let's throw that around there. So that's f1 of 1 minus f1 of negative 5. So, I mean, that I can just copy from what I had before. Negative 1/3, negative 5 cubed, minus 3/2, negative 5 squared, plus 10 times negative 5. And I'm writing on the tablet here, which I'm a little out of practice. Plus, so we had f2 of 4 before, so negative 1/3, 4 cubed, so we're doing this, plus 3/2, 4 squared, plus 4 times 4, minus, let's throw another bracket around that, so that's f2 of 4, minus we're doing f2 of 1, which is just going to be negative 1/3 plus 3/2 plus 4, bracket, bracket. Okay, so negative 1/3, I think we worked that out at some point before. Nope, maybe not. So let's throw that over 6. So over 6, so we've got negative 2. This will be multiplied by 3 minus 9, and this be plus 60. Minus, okay, so this will be negative 125, so this is 125 over 3. All right, I'm going to throw these over 6's. So this is 125 over 3, or 250 over 6. Okay, and it's, so that's a minus there. Okay, so that's positive. Okay, here, so we get 25. So we get minus 75 over 2, so we're going to have to minus 225 over 6. And this is minus 50, so that's going to be minus 300 over 6. All right, so those guys can be collected. Plus. Okay, what have we got here? And have I done this before? Yes, I have. So again, I'm going to go with 6's. Over 6. Okay, so this gives us 64. So minus 64 over 3, so that will be minus 128 over 6. And this is 16, this is 48 over 2, so 48 times 3 is 144. And then this is just 16, so that's going to be plus 96 over 6. And then that's minus, okay, and again, so we put this over 6, and this will be 2, negative 2 over 6. This will be plus 9, and over 6, this will be 24. Okay, so we're going to do these two guys. Let's throw brackets around there. Slide down. Okay, so negative 2 minus 9 is negative 11, plus 60 is 49 over 6, minus 250 minus 225 is is positive 25. So this will be minus negative 275 over 6. Plus, okay, I think that's positive 16. And then we've got 96. So, positive 16 plus 100, so it's like 112. Minus, and what have we got here? That's 731. Okay. So, got 49 plus 275 is, so 50 would give us 325, so 324 over 6 plus, and we've got 112. Wait a second, that's a 31, right? 731, yeah. Okay, so 112 minus 31. 112 minus 30, 102, 92, 82, minus 1 is 81. 81 over 6, which is equal to, we got a 5, so 405 over 6, which reduces to, what are they divisible by? 3? 135 over 2, or 67.5, right? And there's 12 minutes of your life you will not get back. So 67.5. So, yeah, I kind of messed it up a little bit, and it needed to be split at 1 and negative 5 and positive 4, because what I did was left out this area in here. And so now it's back and properly done, and I will append this to the video along with a, notation on the video to say, wait, keep watching, that one's wrong, and we'll fix it up. And so I'm going to do that and append it, and then away we go. So apologies, but hey, this kind of stuff happens, and now it's fixed.